Let's discuss measures of dispersion and coefficient of variation. We have discussed while discussing measures of central tendency that there is problem of outlier. So measures of dispersion, they may correct this problem. So this lecture will be discussed according to following learning objectives. We'll discuss what is range, what is mean deviation, what is standard deviation, how we calculate standard deviation, and what is coefficient of variation, and in the end we'll summarize the session. Dispersion is degree of spread of our variation. So we spread our observation. It helps to know how widely our observation are spread. So we should remember that it shows the spread of our observations, how they're spread. And three main measures of dispersions are used. Number one is range, number two is mean deviation, number three is standard deviation. What is range? Difference between highest and lowest value, or upper and lower limit. Like we mentioned, we can say that upper limit is 16, our upper value is 16, lowest value is 1. Difference between these two is range, or 15 is range. So it gives the information about the values, that about the extent of values. Our values are extending from 1 to 16, or from 1000 to 1 lakh. And what is mean deviation? It is the average of deviation from mean. This is mean deviation. In sigma or summation, we use sign of summation. X is mean, x bar is difference from mean. And standard deviation, when we take square root of squared mean deviation, this is standard deviation. It is the most important, and it's a common university question. Most important and widely used measure. Which one is widely used measure? Standard deviation. What is formula of standard deviation? You must remember standard deviation is equal to the summation x minus x bar, its square, divided by n. N is number of observations. And what is coefficient of variation? It is used to compare attributes having two different units, or having two different units of measurement, like height. Height may be different, height may vary, weight may vary. Coefficient of variation is noted by CV, and its formula is standard deviation multiplied by 100 divided by mean. Like standard deviation is 2, for example, and we multiply this standard deviation with 100 and divide it by mean, and let's suppose mean is 20. So what will be our answer? 200 divided by 20. Coefficient of variation is 10. So remember its formula, standard deviation multiplied by 100 and then divided by mean. It is expressed in percentage, so we write 10%. Let's take an example that in a given data, these are the number of observation: 83, 75, 81, 79, 71, then 95, then 75, then 77, then 84, and 90. This is the systolic blood pressure of a population of 10. The total number of observation n is equal to 10, and this is the systolic blood pressure. We donate it with x. What is mean of this value? When we calculate this mean, we add them and then divide by total number of observation, which is 10. Our answer is, let's draw a table. Mean is 81. We write number of observation, and in the front we write the mean. Mean is 81. Every figure has 81 mean. We write 81. So now we will find the mean deviation x minus x bar. X minus x bar. We subtract x from x bar. Answer is 2. Answer is minus 6, 0, minus 2, minus 10, 14, minus 6, minus 4, 3, and then 9. So minus sign is ignored. We ignore minus. We just add all of them. If we add all of them, our answer is 56. 56 is total mean deviation. We can calculate range from this mean deviation also. Like we say that 56 is mean deviation. Total number of observation was 10. So individual mean deviation is 5.6. And we can calculate the range. Mean was 81. So we can say that mean plus minus mean deviation. Mean is 81, mean deviation is 5.6. This is the range. We can calculate the range in this way also. So how we will calculate standard deviation? That's very simple. We take the square of each value. Like in the previous table, we can take square of 2, 6. We can take square of 2. We can take square of 6. We can take square of 3 and 2. Then we can take square of 10 and 14. So then we can take square of 6, 4, 3 and 9. 6, 4, 3, 9. We need to take care of independent values to calculate standard deviation. Our answer should be 4, 36, 9, it is 4. Square of 10 is 100. Square of 14 is 196. Square of 6 is 36. Square of 4 is 16. Square of 3 is 9 and square of 9 is 81. When we add all these values, our answer is 482. So what is standard deviation? Square root of this, square root of x minus x bar. So we take 482 divided by total number of observation n minus 1. Now question arises, why n minus 1? To avoid sampling error, remember this can be a MCQ. To avoid sampling error, we do n minus 1. We subtract 1 from total number of observation. Why? If total number of observation is 30 or greater than 30, then formula will be x minus x bar over n. We don't need to minus 1 because it is sufficient sample instead. But if the number of observation is less than 30, we subtract 1 from the total number of observation. Like total number of observation is 10. So we subtract 10 minus, we write 10 minus 1. So our answer will be 482 minus 9. Our answer will be 7.31. 7.31 is the standard deviation in this case. Remember two things. First, we need to take square of x minus x bar. Then we need to add them. After taking square of all the individual values, we need to add them. Like in this case, our answer is 482. And we have total number of observations 10 or 10 are total number of observations. So we need to minus and we need the formula n minus 1. If total of number of observation is 30 or greater than 30, we can just divide this x minus x bar with number of observations. So 7.31 is our answer. We can calculate the range, mean plus minus standard deviation. Range can be calculated this way. Mean is 81 plus minus standard deviation is 7.31. So measures of dispersion are used to correct the mistakes of measures of central tendency, to correct the problem of outlier. They show spread of data. We can calculate range, we can calculate mean deviation, we can calculate standard deviation, and we can calculate range from mean deviation and standard deviation. This is the common university question. Remember, n minus 1. Why n minus 1? If sample size is less than 30. Why we do this? To correct sampling error, to correct sampling mistakes. So in the end, we will summarize. We have discussed measures of dispersion and coefficient of variance. What are various measures of dispersion? Range. It can be a question. It can be a university question. It is commonly asked. What are various measures of dispersion? What they show? Measures of dispersion show the spread of data. We can have a better idea what is the highest value, what is the lowest value, because mean can deviate from highest and lowest value. So we consider or we calculate measures of dispersion. They are range, mean deviation, and standard deviation. What range shows? What is range? Difference between highest and lowest value is range. Simply, highest value is 20, lowest value is 4. We subtract them, and our answer is 16, which is range. Then we discuss mean deviation, deviation from mean. To calculate mean deviation, remember one thing, we have to calculate mean, then we can calculate mean deviation. As in our value, mean was 81, total mean deviation was 56. So we calculate mean deviation and then we can calculate range from this mean deviation. Mean deviation gives a better idea which about highest and lowest values. Mean is closer, our range is closer to highest and lowest values. Then how we will calculate standard deviation? To calculate standard deviation, first we need to calculate mean. Then we need to calculate mean deviation. Then we will calculate standard deviation. Mean is simple average. Mean deviation, deviation from mean. When we take the square, then we take the square and we calculate standard deviation. Formula of standard deviation is summation x minus x bar square divided by n, and summation x minus x bar square divided by n minus 1. In our case it was n minus 1 because total number of observation was 10. 10 is lower sample size because mistakes can occur. If we take too small sample, there will be mistakes. Like we have a class of 300 students, 300 medical students, and we take our sample size is 5. This sample can have mistakes. It is not necessary that this shows the whole class or characteristics of whole class. Sample ideally should be 10% of the total population. So to avoid these mistakes, to correct these mistakes, we use n minus 1. Remember one thing, in the exam, you will be given 10 values, or you can be given 15 values or 5 values. It is almost impossible that the observer or examiner gives you more than 30 values. So remember n minus 1. We have solved a university SCQ. Standard deviation is a common SCQ. We have discussed few MCQs, n minus 1, what is standard deviation, what is range, and what are measures of dispersion, then coefficient of variation. Then we discussed coefficient of variation. Formula was standard deviation into 100 divided by mean. In biostatistics, you must remember the formulas. You can do calculation with these formulas, like in a given set of data. Let's take an example. Standard deviation is 10 and mean, they say that mean is 200. Calculate coefficient of variation. So we will apply formula. Standard deviation is 10. We multiply this by 100 and divide it with mean. Our answer will be 1000 divided by 200. The coefficient of variation will be 5%. This you need to remember the signs also. It is expressed in percentages. So coefficient of variation is 5%. So we solved mean deviation, standard deviation, and coefficient of variation. Till then, we have discussed data, presentation of data, measures of central tendency, and measures of variability. Biostat is the continuation. We'll continue this in the next session. That's all.